Hello, everyone. I'm Aaron Spalding. I'm a graduate student at the University of Connecticut, and I'm excited to talk a little bit about NASA and some NASA projects that I've been working on. A lot of people think that NASA is primarily focused on space exploration, but a lot of research and work at NASA is actually focused on helping us understand the world around us, whether that's collecting data sets, or developing models, or doing analysis. There's many ways that NASA relates to us that's not just space. But before we talk about that, I should probably introduce myself. Before I was a graduate student, before I was an undergraduate student, I was actually in a HUNCH program. So in 2016, I was a senior in high school, and NASA HUNCH introduced this tape dispenser problem to us. The goal was to design a tape dispenser for the International Space Station, and this may seem really simple on Earth, but there's a lot of extra factors that you have to take into consideration when you design something for space. Things like weight matter a lot more when you have to fly it to space. Things like exposed edges or blades might not make a difference on Earth, but in space, when there's no formal ground or like ceiling, then it makes a lot of difference, and it could put astronauts in harm's way if it's not protected. And so we worked on that year. In 2017, we presented our working prototype to NASA engineers, and then most of us graduated. I continued as a NASA HUNCH mentor for a year, and other high school teams worked to finalize the prototype, work on future iterations, and get all of the approvals needed to go to space. This design on the right shows our final prototype that went to space in 2021. And last year, Dr. Gold contacted me and asked me to talk a little bit about modeling and space exploration and how it relates to us. And I highlighted two important main points. One, that models tell us about possible futures, and two, that models help us understand the world around us. One of the data sets I really talked about was this one that's shown on the left here. It's this land cover and land use change information data set. Basically, this data set is compiled from NASA satellite scans of the Earth. This is compiled globally, and it quantifies the amount of vegetation, or the different type of land use, or the change in vegetation over time in different parts of the world. And this is really valuable because it helps us to understand how the world is changing, but then also helps us to build models about the world around us. And these models might not be perfect, they might not represent actual physical processes, but they might represent something that's occurring that might give us a framework to think about this. One real-world example is this model that we have at the Eversource Energy Center. So Eversource is the largest energy distributor in the Northeast United States. All this means is that Eversource supplies electricity to consumers and houses from the main transmission lines. And so what we do at UConn is we research outages, so things like line failures or pole failures or transformer failures, and we have an operational outage prediction model. All this means is that we do our own weather forecasts. We do this using numerical weather prediction on the UConn supercomputer, and we have machine learning models built on top of these weather forecasts. These machine learning models contain NASA satellite land cover data. They also use NOAA weather data. They use our own forecasts. They use U.S. Population data, infrastructure data from Eversource, things like drought variables from the U.S. Forest Service, things like parasite amounts for trees in different areas that might cause increased tree failure, drought indices, and all of these go into our models and help us predict tree failure. We do this for every single storm, and this allows us to predict the number of failures in different regions. And this allows Eversource decision makers to pre-place trucks prior to events. And so an event that might have taken them 3 or 4 days to fix before might only take 1 day now, since all of the crews are ready and they know where the outages will be distributed. So this is something that is happening now in real time that actually affects people in the world. And this wouldn't be possible without this satellite data from NASA. Another example is this storm that happened in northern Italy. Storm Via came through. It's a big extratropical event with lots of precipitation, very high wind speeds, and it just knocked down lots and lots of trees. You can Google pictures of Storm Via, that's Vaia, and you can see forests of trees where every tree is on the ground, 100% tree failure. And so we've been working to build models to help understand how this happened and what caused this, but then also ask the question, can we predict tree failure? If we can predict tree failure, then we can predict occurrences of mass tree failure ahead of time, and possibly save lives or prepare people to be prepared to clean this up. Things like mass tree failure caused increased parasite risk. They increase the risk of forest fires. It's really bad for infrastructure, and unexpected tree failure is not can harm humans. It's not safe. I've also used NASA datasets at Brookhaven National Lab. That's a Department of Energy national lab, where we were looking at outages in New York State. The main thing I wanted to talk about today was the impacts campaign that's occurring right now in the Northeast United States. And this stems from our lack of understanding about winter events and what causes precipitation to form and how do we model that. And the first step in that process is to collect data. If we collect data, we can more accurately understand what's happening, but then we also know how we might be able to model things like snowflake size or precipitation density or mixtures of precipitation. We right now are no one's very good at predicting winter events. This is why if you live in the Northeast and you're waiting for a snow day for your school to be canceled, you probably won't know until the night before or even the morning of. And this is just because we have very high uncertainty when predicting winter events. We don't know for certain what the mixture of precipitation will be. We don't know even how much water there will be in total. We don't know what the shapes of snowflakes will be. The shapes of snowflakes drive the type of precipitation, how much it sticks to each other, the type of snow that falls. We can't predict any of this. And if we can't predict it well. And so this sensor on the left here is really cool. It takes photos of snowflakes. It allows us to track snowflakes and look at the velocity, but then also the shape and the size. The sensor in the middle is a micro rain meteor radar. We also have laser sensors to measure the size of precipitation, sensors to measure the total amount of snowfall, as well as other sensors such as radar on a truck, and a bunch of other custom-made sensors that will be arriving and installed this winter. In addition, we also will be flying planes over the Northeast United States, and these planes will be dropping sensors. These sensors will record information as they fall. They'll record things like altitude or pressure, and we can collect this data and then use it to help model the shape of clouds and the types of clouds, and also what's inside the cloud, like what's going on, what shapes are the raindrops, what's the composition of the precipitation, and so on. And if we're able to model the types of clouds, we might be able to model types of precipitation. And this helps us form better forecasts. We'll also be launching balloons and doing things on the ground as well. But this is just another campaign of NASA that highlights how NASA affects real-world scenarios on Earth, and how NASA isn't just about space exploration. NASA affects us in way more ways than you might expect, and it really plays a role in your life right now, and you might not expect that. Thank you for listening to my presentation. If you have questions, you can email them to Dr. Gold and she'll forward them to me. Thank you.